Hi students, let me start today's class with recalling the two important theorems. That's theorem 10.1. Tangent at any point of circle is perpendicular to the radius through the point of contact. So this radius will be always perpendicular to the tangent. And by theorem 10.2, the length of tangents drawn from an external point to a circles are equal. So from the external point, there is a possible to draw a two tangent, and the measurement from that external point to the point of contacts will be equal. That's why written PQ is equal to PR. So here we go for the problems. If a tangent PA and PB from a point P to a circle with center O is inclined to each other at angle of 80 degree, then find angle POE. So first we have to draw the figure. So here is a circle and the tangent PA and PB. You can see the P is the common, so the point which is outside is the P. So from here there's a two tangent. This will be this point of contact, let me consider as a PA, and this point of contact let me consider as a PB, and here will be the radius, sorry, center. Oh, okay. And they said that from the both are point P to the circle with center O is inclined to each other at an angle 80 degree. So this inclined angle is a 80 degree. And we have to find POA. So let me connect this P and O. And they said to find POA. POA. And this is a tangent and this is a radius. We know that this is a perpendicular, that's 90 degree, and this full angle is 80. We have to know what is this angle alone, right? So let me connect this OP also, and this also forms a 90 degree. And if we prove that both are similar or a congruent, then we can find this angle, right? And that is easy, right? We know this angle is 90 degree and this angle is 90 degree, and this is a radius and this is the radius, and this both tangent are equal by the theorem 10.2, right? So this both will be the similar and this angle will be the equal, so it is also 40 degree. So but we have to write it, right? So what we have constructed here, construct draw OP, OA and OP. So now we are going to consider the two triangle. So let me consider in triangle the OA, OP, and here BOP, triangle BOP. So here the angle are equal, right? So angle A is equal to angle B is equal to 90 degree. You have to write the reason. How? By theorem 10.1, right? So next, this OA, here is the OA. OA will be equal to OB. So this both will be the radius, clear? And this PA will is equal to PB. How? It's a tangent drawn from the external point. So this both the measurements are equal. Where it says? It says from the theorem 10.2. So now we can see this angle and two included sides. So this both will be SAS. So by SAS similarity criterion, we can say that both triangle OAP is similar to triangle, so OA and OA, here it will be a OB, both radius equal, right? OB and PEP are the same, are similar. If it is similar, we know that sides are in the proportions and angles will be the equal. So here this both angle have to be equal. So this angle is APO. So angle APO have to be equal to angle OPP, right? So by this we say by CPST, corresponding parts of similar triangle, right? By CPST, corresponding parts of similar triangle. And we know that full angle is, angle APB is equal to 80 degree. Then this both are equal, then it should shares equally, right? So this angle, the angle which we need APO will be 40 degree. That means half of angle APB, that's a 40 degree, right? Now we know this angle alone is a 40 degrees. The 80 is actually full angle. So now we know this is a 90 degree and this is a 40 degree, and we can find the rest. How? The angle sum properties of the triangle, right? So by angle sum property of the triangle, so what will be the sum of all angles is 180 degree. So how many angles are here? Angle OAP, angle OAP plus angle APO, angle APO plus angle POA. That's what we have to find, POA, right? So if we add, it have to be 180 degree. We know that angle OAP is 90 and this is a 40. So 90 degree plus 40 degree plus angle POA is equal to 180 degree. So if we add, we will be getting it as a 130. So angle POA is equal to 180 degree minus 130 degree. So if we subtract, the angle POA will be equal to 50 degree, right? So while drawing, we got only the two tangent, but after we joining is we got as a two triangles. So by proving that similarity, we have found angle, one of the angle, and another angle is already, we know this 90 degree by theorem. So we have found the rest, that what we need, POA. So here we go for the next problem. Prove that the tangent drawn at the end of the diameter of the circle is parallel. So we have to construct a circle. So let's consider this as a circle, and I'm going to draw a diameter. So let me consider this as the diameter, and you have to prove that tangent drawn at the end of the diameter. This is the end. So two ends are there. So here I'm going to draw one tangent, and here another tangent. Clear? And we have to say this both are parallel. And if it is the parallel, if any two lines parallel and it's like the diameter is touching the two parallel lines, right? Consider this is a parallel and this diameter touching the two parallel line. We have learned about this, right? The line which cuts the two parallel line, that's a transversal line. So we are going to prove with that concept. So here AB is the diameter of the circle. Let me consider that. Okay, and let this be the line P and let this be the line Q, center be O. So what we have constructed, we have to write. So AB is diameter of the circle, and P and Q are two tangent, right? So we know that this is the radius and this is the tangent. So it is 90 degree and this is also 90 degree. The same way here also forms a 90 degree. So let me consider this angle 1 and angle 2. Let me say that 3 and 4, right? So if it is the transversal, we know that opposite interior angle should be equal. We know that all angle 1 is equal to angle 2 is equal to angle 3 is equal to angle 4 is equal to 90 degree. By which theorem? By theorem 10.1 we know it. So the interior opposite angles we have to check whether it is equal or not. So equal 1 is equal to angle 1 is equal to angle 4. The same here, the 2 and 3 will be is equal. So by transversal AB. So here the transverse is the diameter AB, which makes equal interior alternate angles, right? So therefore line P and Q must be parallel, right? Even one more condition we can use this that way. Interior same side angles is supplementary. Sure, this is 90 degree, right? 90 degree plus 90 degree is 180, which is supplementary. Even by that also we can prove this problem. So here we go for the next problem. Prove that the perpendicular at the point of contact to tangent to a circle passes through the center. So let me draw the circle. So this is the circle. Let me consider the tangent here, a line. Let me call it as an xy. And we are going to draw one perpendicular to the point of contact. So this point is the point of contact. And I'm going to draw a perpendicular to that one line here, right? So I'm going to draw as a perpendicular. Let me call this and this point as a A and this as a B. Okay, and perpendicular at a point of contact I have drawn to the tangent, and a circle passes through the center. So this line, if it is extended, it must passes through the center. That is what we have to prove, right? So perpendicular at the point of contact. So at the point of contact I have drawn a perpendicular, that is A, B, Y is a perpendicular, and to the circle passes through the center, and this line it have to passes through the center. That is what they are saying. So first what you have drawn, we are going to write xy is a tangent to circle at B, right? At B. So at the circle it is up at P. And one more we have constructed, AB is perpendicular according to the question. AB is perpendicular to XY. Clear? So next we have considered the B and O, right? Join BO. So we have to say it is a straight line. They said it passes through the line. So this line is passed, it is not bend or it is not joined the two center like this, we have to say. So it is enough to say that it is the straight line. So another the way to say the straight line, the 3 points are in the collinear, we can say any of things we can see. So we know that, so it is given that an angle ABY is the 90 degree. How it is given that they are saying to it's a perpendicular. And next we know that this radius and this tangent will be 90 degree. So angle OBY is equal to 90 degree. So this is by theorem 10.1, right? So if you add this angle ABY plus angle OBY, we will be getting it as a 180 degree, right? 90 degree plus 90 degree. So this should be the straight line. So if it is, you know, only the straight line will having a 180 degree. So therefore the ABO are a straight line. ABO are straight line without any bends, right? So therefore AB passes through the center of the circle. Sure, because why? The OB is the radius. Sure, it have to pass to the center, and the line which join AB also have to pass it to the center. So here we go for the next problem. Two concentric circles are of radius 5 cm and 3 cm. Find the length of the chord of the largest circle which touches the smaller circle. So two concentric circle, we have to say concentric circle is nothing. From the same center point we have to draw the two circle. So with the help of the compass I have drawn from the center O. With the same center I am going to draw one more circle. So another circle is drawn from the same center. It is called the concentric circle, and are of the radius 5 cm and 3 cm. So the bigger one is 5 and smaller one is 3. Find the length of the chord of the larger circle which touches the smaller circle. So chord we are going to draw for the larger circle, but it have to touch the smaller circles also. So from here I'm going to draw it a chord and touches the smaller circle, and we know this radius is a smaller one is 3 centimeter and the bigger one is 5 centimeter, and we know this is a 90-degree. So let me name it OP and this chord be the AP. We can name it anything. So the radius larger circle radius, what is the radius? OB, right? So OB is equal to 5 centimeter and smaller circle radius OP is equal to 3 centimeter, and we know that OP is perpendicular to AP. How this? By theorem 10.1. You can write that radius through point of contact is perpendicular, right? So therefore so it is possible to find a PB, and we have to find a AP also. AB, both the length we have to find, right? And we already know, so this both will be the similar. So if it is enough to find the BP, and this also will be the similar. Since this side is also the radius same, right? This side if you drawn also, you will get a same radius as a 5 centimeter, and it's like a similar triangle. So we can just enough to find a BP and we can share them. So in triangle OPB, so by Pythagoras theorem, we can say that hypotenuse side is an OB, right? So OB square is equal to OP square plus PB square. So OB square is 25 is equal to OP square is 3 is 9 plus PP square. So if you bring 9 is subtracted, so PB square is equal to 25 minus 9 is a 16, and if you take a square root, we will be getting as a PB is equal to 4. So plus or minus 4 will be there, but length negative is not possible, so we are not considered. So PB is equal to 4 centimeter. Then what will happen to AP? AP will also the 4 centimeter. Similarly we can prove, right? Similarly we can say that AP is equal to 4 centimeter, but we have to find the length of the entire chord. So that is a AP plus PB. Length of the chord is equal to AP plus PB, which is equal to 4 plus 4, that is 8 centimeter. Clear? So we have found a chord by finding the two sides, since it forms a right triangle, and it is also equal right triangle. Two right triangles forms and is also equal, right? Since we can see by this OP bisects AP of the chord, since it is a radius, right? Thank you.